In physics, there are two types of physics. One is classical physics and another is called quantum physics. Classical physics is the physics which has been given to us by Newton. Whatever physics applies to large body, for example, force is equal to mass 1 upon mass 2 upon r square and constant, or the laws of motion, inertia and so on. Majority of the things is given to us by the Newton, and that is called classical physics. And that was given to us by Newton. But what Einstein and probably Maxwell gave to us were quantum physics. Quantum physics are the set of rules and equations which applies to smaller things like electron, proton and so on and so forth. And these are considered to be two separate physics which don't interact. These laws of physics of classical doesn't exist in quantum and classical. Of course, if you collapse the quantum equation, it becomes classical, but the features of classical and quantum are very much different. So one of the features is called quantum tunneling. For example, consider an electron. An electron can pass through a barrier without interacting with the barrier. This is called quantum tunneling, and this is the property of quantum physics. Of course, this doesn't happen in the classical physics. I just can't pass through a thick barrier without interacting with it. I have to interact, I have to tear it or jump over it with enough energy. But recently, three physicists, what they did, they made a circuit and they cooled down the temperature. So definitely the electrons in them loses energy, and they made a fake barrier, light barrier, and there was a bulb on the other side. Despite this, what they found that the billions of electrons jumped the barrier and the bulb was on. That means billions of electrons, which is not a quantum thing anymore, because a quantum thing is an electron, but a billion electron is a classical thing. And despite it being cold and having no energy, it somehow passes through the barrier and the bulb is on. And there is only one explanation for it: quantum tunneling. So that's what is the special thing about this year's Nobel Prize in Physics. And the implication of this is maybe 50 years from now we'll figure out a way to extrapolate that equation to our thing, to all the larger classical bodies, and maybe you and I can do quantum tunneling and pass through the hard barrier. See you guys.